Good evening, everyone. This is Mike coming back at you with another video on Intro to Algebra. In this video, we are beginning a new chapter. We're going to talk about Chapter 5, and we're going to begin by talking about the greatest common factors and factoring by grouping. So we're going to talk about this not just with numbers, but with terms of polynomials and then just polynomials overall. So when we talk about factors, we talk about the numbers, specifically the whole numbers, or the expressions or the terms that multiply to give us something. So the first couple samples here I have are just numbers. So 2 and 6 are factors of 12 because 2 times 6 is 12. There are other factors of 12. There's 4 and 3 because 4 times 3 is 12. The next sample here is 10 and 3 are factors of 30, as well as 2 and 15 because 10 times 3 gives you 30. 2 times 15 gives you 30. Some examples of factors that don't involve numbers or just numbers, I should say, things that are involving variables, say, x and x plus 2 are factors of x squared plus 2x, since x times x plus 2 is equal to x squared plus 2x. So if two things, call them capital A and capital B, multiply to give you something else, capital C, we say that capital A and capital B are factors of capital C. One more example here where we're talking variables or algebraic expressions or something like that, something along those lines. X minus 1 and x minus 3. I didn't need to put the grouping symbols on there, but I did. X minus 1 and x minus 3 are factors of x squared minus 4x plus 3 because, B slash C, if you do x minus 1 times x minus 3, you will get that x squared minus 4x plus 3. So that's why we say that these two things, x minus 1 and x minus 3, are factors of this thing right here because they multiply to give us this thing here. So sometimes two numbers or two algebraic expressions, but for now we'll just focus on the case of just numbers. If two numbers have a factor that is the same, this factor is called a common factor. And we are specifically interested in finding the greatest common factor. Now, these examples that just involve numbers, we've certainly dealt with this. We've seen this popping up several times so far. So this is really nothing brand new to us. I just wanted to sort of hammer home these concepts because we're going to see how they scale up and how we use them with things that are now involving variables like x's and y's and all those things. So we're interested in finding the greatest common factor. We want the largest number that is a factor of any two given numbers. A couple samples here. The GCF, or greatest common factor, of 18 and 24 is 6. Because if you listed out all the factors of 18 and all the factors of 24, you would find that the largest number that's in common to both of those lists is 6. I can go 1, 18, 2, 9, 3, and 6 there. And then for 24, I can go 1, 24, 2, 12. I have 3 and 8. And then I have 4 and 6. So if you compare these two lists of numbers, what's the largest number that lies in both of these lists? It's 6. So that's why we say that 6 is our greatest common factor. The GCF of 5 and 7 is actually 1, because 5 is only 1 times 5. So 1 and 5 are the only factors, and 1 and 7 are the only factors of 7. So the largest number in common to both of those lists is 1. So just some more practice with finding the greatest common factor of any two given numbers. You can, sort of start to think of, okay, what are some factors of each of these numbers? So let's go with 50. We have 1 and 50. We have 2 and 25. We have 3 doesn't work, 4 doesn't work, 5 works. We have 5 and 10. And then 6 doesn't work, 7, 8, 9, and then 6, 7, 8, and 9 don't work, and then we're back at 10. So that's it. For 65, I have 1 and 65. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works. I have 5 and 13. Those multiply to give me 65. 6 doesn't work, not 7, not 8, not 9, not 10, not 11, not 12, and then we're back to 13. So what's the largest number that's in common to both of these lists? It's going to be 5. So 5 is our GCF of these two numbers. This case right here is kind of a neat case. If we list out all the factors of 36, well, we have 1 and 36. I have 2 and 18, 3 and 12, 4 and 9, and then there's 6 times 6, but we only write the 6 once. 72 is 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and then 8 and 9. So actually, what is the largest number in common to both of these lists? It's actually 36. And it was one of the two numbers that we were given to work with at the start. So sometimes your GCF is actually one of the two numbers that you were handed at the start. Now, these numbers weren't too bad. Yes, some of these numbers did have lots of factors, like, say, this one here. So there was sort of a lot of listing that we had to do. So that can get tedious, that can get kind of tiresome. So what's another way that we can sort of do this to make this a lot nicer? Perhaps maybe make it easier on us. So I offer this following way to sort of make this easier on us. And it can be easier when we're trying to find the greatest common factor between 3 numbers and not just 2. Sometimes we need to write each number in its prime factored form to find the GCF. Once each number is written in its prime factored form, the GCF, the greatest common factor, has each prime number used the least number of times it appears between all of the factored forms of each of your 3 numbers. So what we're going to do is we're going to write each number in prime factored form. We're going to see what primes are being used amongst all of the numbers. And whatever is the smallest exponent on that prime, that is going to be the exponent of that prime in the GCF. So if we start off with 50 here, 50 is 2 times 25, and 25 is 5 times 5, or 5 squared. So 50 is 2 times 5 squared. And 2 and 5 are prime numbers, so we have to stop there. 75 is 3 times 25, and that is 3 times 5 squared. And 105, so 2 is not a factor, 3 is a factor. I have 3 times 35 will give me 105. And now 35 is 5 times 7. And 3, 5, and 7 are all prime numbers. So we stop here, we say, okay, what are all of the primes happening in any of these 3 numbers? I see 2, I see 3, I see 5, and I see 7. And I'm purposely leaving some space here after each number because we have to figure out what the power is going to be. So now, I look at what is the least power that is happening on each of these primes between all of our numbers. Now we see the 2 is happening in this number once, but it's not showing up in either of these 2 guys. So what that's telling me is that there's no 2 in either of these numbers here. So the 2 is not going to show up in my greatest common factor. Secretly, what's going on here is that these numbers have a 2 raised to the power 0. So you could write 2 raised to the power 0, or you could just not have it in their period. So we'll just cross that out. Now let's look at the 3. The 3 is in this number, it is in this number, but it's not in this number here. If it's not in all of the numbers, it's not going to show up in our greatest common factor. So we can just cross that guy off too. All right, the 5. The 5, unlike the previous 2 primes, the 5 is happening in all 3 of these numbers. So what we are going to do is we are going to take the smallest exponent that's on the 5 between all these numbers, and that is going to be the exponent on the 5 in our GCF. So secretly we have a power of 1 there, there's a power of 2 there, and a power of 2 there. So we're going to use the smallest exponent, which is the 1, and that's going to be the exponents on the 5 in my GCF. And lastly, the 7. The 7 is only showing up in 105, but not in 50 nor 75, so we don't include it. So the GCF is just 5 to the power 1, or 5. And this is another way that we can find our GCF. I'll let you try this one on your own, thinking of that same process. So that's how we could find the GCF with just numbers. But what if we have variables and exponents on the variables, as well as some numbers in front? So how do we find the GCF of something like that? the GCF of terms with variables and exponents is going to be the GCF of the numbers in front, aka the coefficients that you have on each of those terms, as well as the least exponent amongst all variables of the same type in each term. So here is some clarity as to what I mean. If I have x squared, x to the fourth, and x to the fifth power, each of these terms has the same variable, x, and each one is raised to some power. We're going to take the smallest power that there is, and that is going to be the exponent on the variable that's in my GCF, because I can write x squared as just 1 times x squared. I can write x to the fourth as x squared times x squared, and I can write x to the fifth as x squared times x cubed. So these are common factors. So x squared is the greatest common factor between these three things. And x squared is obviously 1 times x squared. It gets a little bit more involved if you have more than one variable happening. You have to take the least power, the least exponent or the smallest exponent on each variable, and that is the part of your GCF. So here I have x times y squared, x cubed times y cubed, and x to the fifth times y to the seventh. I'm going to focus on just the x's first. I have the x cubed, and the x to the fifth. What is the smallest exponent on the x variable? It's the exponent of 1. So x raised to the first power, or just x, that is going to be the factor, or that is what is going to be involved in my GCF of these terms. Now looking at the y squared, the y cubed, and the y to the seventh. Again, we're going to have the variable y showing up in our GCF because it is in all three terms, like it happened with the x's. We had x's in all three terms, so the x will show up in the GCF. Same kind of thing with the y's. The y is showing up in all three terms, so the y will show up in our GCF. What is the exponent going to be on that y? Well, it's going to be the smallest of the exponents on the y's in those three terms. So the smallest of 2, 3, and 7 is 2. That's why we have 2 as the exponent of y in our GCF. So let's get some practice with finding some GCFs here. So I have x cubed, 2x squared, and 5 times x to the fourth. What is the GCF of this thing? Well, one part of it is going to be the greatest common factor of the numbers in front of these x's being raised to powers. So secretly we have the 1 in front. So I need to find the GCF of 1, 2, and 5. Well, this is pretty nice. The GCF is actually just going to be 1. So we can say it's 1 times. And now, is the x going to happen? Is the x going to show up in my GCF in any way, shape, or form? Well, each of these terms has an x, so the x is going to show up in the GCF. The question is, what is the exponent going to be? And the exponent is going to be the smallest exponent that we see amongst these three terms. So the least exponent of 3, 2, and 4 is 2. So the GCF of these three terms is going to be 1 times x squared, or just x squared. Next one here, the GCF of these 4 terms right here. So again, I need to find the GCF of the numbers in front, 3, 9, 6, and 12. Well, that would be, you can factor each of these things, and you can find that the greatest common factor amongst those 4 numbers is 3. Now, the greatest common factor amongst the x's, if there is one, well, we see again that the x is showing up in each of our 4 terms. So the x is going to appear in the GCF. The question is, what is the exponent going to be? Again, we're going to look at the smallest exponent on the x's. So what's the smallest exponent of 6, 3, 4, and 7? That's going to be 3. So the GCF here is 3 x cubed. We'll do this one here. I'll let you try this one on your own. This one is a bit more involved. Some more things that we have to take a look at. The GCF of these 4 terms here. First of all, we need the GCF of the numbers in front. 2, 4, 10, and 30. If you use the method that we talked about earlier on in this video, you will find that the greatest common factor of these 4 numbers is just 2. Now we have x's and y's happening in these terms, so I have to do sort of the same check, one with x's and then one with y's. Each of these 4 terms, there is an x happening. So the x will appear in the GCF. What is the exponent going to be? Well, exponent here is 1, here it's a 4, here it's a 1, here it's a 2. The smallest exponent is 1. So we're just having x, or x to the 1. Now, there's y's happening. Y cubed, y to the 8th, y to the 5th. Oh, but there's no y happening here. If the variable is not happening in all of the terms involved, then that variable is not going to appear in your GCF. Just like it didn't appear in the GCF if it was not a prime number that was a factor. If the variable does not show up in all of the terms, it's not going to show up in your GCF. So we have to stop here. There's no y showing up in our GCF, so the GCF is just 2x. So guys, that concludes this video. In the next video, we will pick up where we left off, and we will talk about pulling out this GCF and really get into factoring the polynomial, specifically factoring out the greatest common factor. If you guys have any questions or comments, be sure to reach out to me. You know how to get a hold of me: email, phone call, stop into my office hours, stop into my tutoring hours, whatever you have to do. Until the next video, take it easy, guys.